We are supposed to find out the tension BD and tension BE. As usual, the formula is very simple. You have to calculate tension BD vector. It's nothing but tension BD value multiplied by lambda BD vector. Here the lambda BD vector is OD vector minus OB vector by magnitude OD vector minus OB vector. So this again TBD multiplied by OD vector minus OB vector. Here we have OD vector 0i, 2.1i plus 1.8k and OB vector as 1.8i. So OD vector minus OB vector is this. OD vector is 0i plus 2.1j plus 2.1j plus 1.8k minus OB vector is 1.8i plus 0 vector j, 0 k vector, the whole thing divided by the magnitude OD minus OB. So this implies lambda tension BD vector is equal to tension BD multiplied by 0 minus 1.8. So this is nothing but minus 1.8i minus 1.8i then the second term is plus 2.1j, third term is 1.8 minus 0, it's nothing but 1.8k, the whole thing divided by square root of 1.8 the whole square plus 2.1 the whole square plus 1.8 the whole square. Therefore, we can very easily find out that tension BD vector as tension BD multiplied by minus 1.8i plus 2.1j plus 1.8k, the whole thing divided by this value we can very easily find out. Let us say square root of 1.8 the whole square plus 2.1 the whole square plus 1.8 the whole square. So the value is 3.3. So this is one tension vector. Similarly, we can find out tension BE vector also. Tension BE vector is nothing but tension BE multiplied by lambda BE vector. Tension BE multiplied by lambda BE can be rewritten as tension BE multiplied by BE vector divided by magnitude BE, which is BE vector. This can be once again rewritten as tension BE multiplied by OE vector minus OB vector by magnitude OE vector minus OB vector. So this implies tension BE vector is equal to value of tension BE multiplied by OE vector is I plus 2.1j minus 1.8k, 0i plus 2.1k minus 1.8k, the whole thing minus OB vector is 1.8i plus 0j plus 0k, the whole thing divided by the magnitude of this value is nothing but 0 minus 1.8 is minus 1.8, so it is nothing but 1.8 square. 2.1 minus 0, we will get 2.1 square. Similarly, minus 1.8 is 0, we give once again minus 1.8, we can square it. So the minus sign has no effect on it. We can straight away take this as 1.8 square. When we take these values, 1.8 square, 2.1 square and 1.8 square, the same thing we are getting here. So we can take 3.3 straight away. So this implies tension BE vector is equal to tension BE multiplied by 0 minus 1.8, it's nothing but minus 1.8 I vector, 2.1 minus 0 plus 2.1 j vector, minus 1.8 minus 0 gives minus 1.8 k vector, the whole thing divided by 3.3. So it's again the second step answer for the known unknown tension values. So for TBE we get TBE vector. Similarly for TBD we get TBD vector. Yes. First we will apply the moment condition. It is we are going to take moment at point A and we are making it to 0. So when we consider the force A, we get the mass product corresponding to A, that is I, J, K, the unit vectors, and the distance vectors 0, 0, 0, and the component forces for A is AX, AY and AZ. So we can simply ignore because this term is 0. Here we have 0, 0 in a single row. Then we consider the second force, that is tension BD, where the common value for tension BD force is nothing but TBD 0.33 in the force term. So we can take it out. We put the IJK values, I vector, J vector and K vector, and the position vector R regarding TB vector is nothing but 1.80 and 0. So we can enter the values 1.80 and 0. Regarding the force term, we have minus 1.8 plus 2.1 and plus 1.8, minus 1.8 plus 2.1 and 1.8. Then we have a similar term for tension BE, tension BE by 3.3, I values J, then K, the unit vectors. The distance position vector remains the same for BE also, because tension BE act at B only. Then the force vector terms are minus 1.8 plus 2.1 and minus 1.8, minus 1.8 plus 2.1 and minus 1.8. We have the last term for the force component 4 kilonewton down. Here is a force component 4 kilonewton at C. So we write that as I, unit vector J and K. The position vector is C, 3I plus 0J plus 0K. So it is 3, 0 and 0. The force component is 4 kilonewton J minus, therefore we have 0 and 4 and 0. The whole thing is equal to 0. See, we expand this box product